Hello and welcome. Today, we're going on a journey, tracing the incredible story of chemistry. We'll go from these ancient, dusty workshops all the way to gleaming modern laboratories. And along the way, we're going to uncover how this science has been secretly shaping our world for literally thousands of years. So let's just jump right in with a question for you. I want you to picture the vibrant colors of ancient fabrics, or the sturdy clay pots people used every single day, or even the first bars of soap that started to change, well, everything. What do all those things have in common? What's the hidden thread that ties them all together? You guessed it, it's chemistry. Long before anyone had ever seen a lab or a beaker, people were performing these incredibly complex chemical transformations. They were absolute masters of a science that they didn't even have a name for yet. And to really wrap our heads around this, we need to go way back. We're about to see that chemistry isn't some newfangled discipline. No, its roots run deep, deep into our ancient past. Just look at the sheer ingenuity on display here. Take ancient India, for example. These craftspeople were true pioneers. They weren't just making a few pots. They were mass-producing pottery and bricks. They weren't just splashing color on cloth. They were using things like madder and turmeric to create these lasting, vibrant dyes. From forging metals in fiery furnaces to crafting soaps from oils, none of this was an accident. This was a really sophisticated, hands-on understanding of how to take one material and turn it into something completely different. So when you really think about it, what this means is that the ancient artisan, well, they were the world's first experimental chemist, right? They might not have worn lab coats, but they were doing the same things, observing, mixing, heating, all to get a very specific result. They were running experiments that quite literally shaped the world around them. Okay, so let's zoom in a bit. Let's really look at one of these transformations. How did they actually do it? How did they turn simple, wet clay into a piece of durable ceramic? What was the science behind the art? Pottery is a perfect example, and it's probably one of the earliest chemical processes humans ever figured out. On the surface, it seems pretty simple, right? You just mix some clay and water, you shape it into a bowl, and then you stick it in a really, really hot kiln. But the change it goes through is just profound. What comes out is nothing at all like what went in. And that brings us to the real question here. On a microscopic level, what is actually happening to that clay? How does a soft, mushy lump of earth become a hard, durable pot that can hold water? To figure that out, we need to understand the fundamental nature of, well, stuff itself. To really get that transformation from soft clay to hard ceramic, we have to look at the very stuff it's made of, what scientists call matter, and how it behaves. And the key lies in a concept you probably remember from science class, the 3 states of matter. Okay, first things first, what even is matter? It's really simple. It's just anything that has mass and takes up space. The chair you're sitting in, the water in your glass, the very air you're breathing. It's all matter. It is the physical building block of our entire universe. And all that matter is made of these teeny tiny particles. How they're arranged and how they move, that makes all the difference. In a solid, like ice, those particles are locked into a tight, neat grid. They vibrate, but they can't go anywhere, which gives it a fixed shape. Now, in a liquid, like water, the particles are still close, but they can tumble and slide past each other, which is why liquid flows. And then you have a gas, like steam, where the particles are just full of energy, zipping around and spreading out to fill any space they can. Now, our ancient craftspeople, they were dealing with both pure substances and mixtures all the time. A chunk of pure copper, that's a pure substance. But the clay they used for pottery, that was a mixture of all sorts of different minerals and water. Being able to understand that difference, even just by feel and experience, was absolutely crucial to getting the final product right. And those ancient potters, they were total masters of changing the states of matter. When they fired that clay, they weren't just drying it out. The intense heat was forcing the water to turn into a gas, steam, and escape, while causing new, permanent chemical bonds to form between the solid particles left behind. They didn't have the scientific theory, but they perfected the practice. Science just gives us the language to explain the magic they were already performing. But, to go from a secret craft that's passed down from master to apprentice to a truly global science, you need more than just a descriptive language. You need a common standard. You need the language of measurement. Think about it. If you want someone on the other side of the world to get the same results as you, whether you're making a new dye or a stronger type of metal, you can't just say, add a pinch of this or heat until it feels right. Science demands precision.
Being able to measure things accurately is what allows an experiment in one lab to be understood and repeated perfectly in any other lab on the planet.
And to solve that problem, scientists from all over came together and created a universal system. This table shows its foundation. It's called the International System of Units, or SI for short. Thanks to this, every scientist everywhere agrees on exactly what a meter is, or a kilogram, or a second. This universal agreement is what turns a local art form into a global science. Of course, to make these super precise measurements, you need super precise tools. This is an analytical balance. It's a device that labs use to measure mass with just incredible accuracy, way beyond what any kitchen scale could do. It's basically the modern, high-tech version of those ancient scales, elevated to a whole new level of scientific rigor. So we've taken quite a trip, haven't we? From ancient arts to the fundamental rules of modern science. Now let's bring it all together and take a quick look at where this path is actually taking us. Here's the most important thing to take away from all this. Those same fundamental principles, controlling heat to change materials' properties, or carefully mixing substances to get something new, that's exactly what chemists are still doing today. The only difference is, now we have a much, much deeper understanding of why it works. And the results of that understanding are everywhere you look. Chemists are designing incredible new materials from scratch, like superconductors and super strong composites. They're manufacturing the fertilizers that feed billions of people and the life-saving medicines we rely on. And today, they are on the absolute front lines of tackling our biggest environmental challenges, like what to do about greenhouse gases. This all leads to a really beautiful idea from the Nobel Prize winner Roald Hoffmann. He said that chemistry isn't really about the 100 or so elements you see on the periodic table. It's about the infinite variety of new molecules you can build from them. It truly is the science of transformation. So, from the very first pot that was ever fired in a kiln to the complex molecules being designed in a lab as we speak, we have always used chemistry to transform our world. It really makes you stop and wonder, with all the incredible tools and knowledge we have now, what are we going to transform next?